So along those lines, I mean, we work together. I been doing materials work with Possible Objects for a number of years. I mean, there's that materials mindset about kind of what materials right for what application. Certainly with the IO technology and the combination of a carbon fiber or composite veil and thermoplastic or thermoset, like you were saying, is pretty unique to the industry. And so, do you want to talk a little bit more about kind of the kind of from your standpoint as the 3D printing, kind of your work in the 3D printing industry has evolved? Like, what are some of the big um, advantages or big kind of pulls of the technology now, specifically with IO's technology, as you're seeing from customers now that it's been 40 years since 3D printing has been around, but you've got new technologies emerging all the time and new material sets.
So for your audience, I mean, we have a number of Air Force contracts that we're doing various types of materials development work. And one of the exciting ones is that we're actually on a development path for doing unidirectional or uniaxial fiber sheets that's going to raise the mechanical properties and the strength properties. Absolutely major pull from various DoD agencies, because now you actually have an additive process at the end of the day that could yield structural types of parts without all the tooling and all the skilled labor and all the expensive capital equipment to make that part. So that's really exciting. Another aspect is the material combinations. I mean, depending on what program you're talking about, what kind of sets of requirements, it certainly has to be developed by people such as yourself. But there's so many like qualified materials out there. Just like, oh, like when I was on the F-18 program, one of the composite systems was an IM7 composite fiber. Well, can we get an IM7 composite fiber sheet that could, the right grade of it, that could run on the IO system? And, you know, they use a different, they had a resin system. Now, can we get a resin system in powder form? And if the answer to that's yes, that opens up a lot of opportunities in what they call the rapid sustainment office and product lifecycle office to make all kinds of spare parts on that front. So that's pretty exciting. But besides material combinations, there's some really interesting things as you kind of look over kind of these emerging programs. I think we all agree that a lot of emerging programs in like electric vehicles or batteries or hydrogen fuel cells. For example, batteries. I mean, there's some interesting material combinations that could potentially be developed and developed for the IO process that could yield really cost-effective components for new battery construction. And you know, we have a thermal set, and so for anything that might be an air vehicle or a drone, so weight is king. So you don't want to do these with metal, and you have battery packs, and if a battery pack catches on fire, that could all be contained with a thermal set battery case. A simple example there. So it's the material combinations, and besides that, it's a technology. We're smaller size right now. You know, we're using basically 12-inch by 12-inch fiber sheets in the process. But far as scalability to larger sizes and faster build speeds, we got plans for all of that. So we can go bigger and we can go faster.